Good morning, everyone. So I'm talking to you. You're watching this on Friday, obviously. I'm on Thursday, so I'm always going to be a day ahead of you or so in preparing this. The good news is that the amount of you managing to send stuff in is increasing. So I had 9 for the ratio problems lessons. 9 of you send me something, upload something that you've done, and that's increased to 16, which is fantastic for the standard form. We really need to get all of you sending something in. For today's lesson, what I'd like you to do is we're going to do a similar thing. The worksheets online that you can have a look at. I'm going to want you to have a go at the very last question, question 13, which there are solutions for online, but I would like you to have a go at that without looking at that first of all, and then mark it with that and just upload me that one question 13, and I will give you, I'm not giving you feedback on the one from the last lesson you've done, but I will look at all of those and I will give you all feedback on that, and that will be the trickiest question on all that stuff that we've done. So do not worry if you didn't manage to get all of it. Now if you want to just do a little have a go at what you've done and then look at the answers, and then using a different color maybe show the bit from where you'd got to, that's fine. And if I'm expecting quite a few of you not to really get anywhere with it before looking at the answer, that's okay, but I just want you to have a go. There's going to be some rearranging of equations to do at the beginning of it. Give it a go. I'll stop warbling on now and get on with the lesson. Here's our first question. Write it down and have a little go at it. What do you think's going on? Right, so the upper bound, we want a rectangle which we've been told is 21 centimeters length and a width of 5.3 centimeters. This has been measured to the nearest centimeter. This has been measured to the nearest millimeter. So what we need to do is, to get the upper bound, is think about the biggest value it could be. So for the first one, 21 centimeters to the nearest centimeter. If we say, right, it's been rounded to 21 centimeters, the next centimeter up is 22, the next one below is 20. What is the largest it could be before it would be rounded down to 21 centimeters? We've got a zone here between there and there at which it would be rounded to 21, and because we're going for the upper bound, I'm interested in the biggest possible value it would be. Now at 21.4 it would round down to 21. At 21.5 it would round up to 22. But what about 21.49 recurring? Because 21.49 recurring goes down to there and is actually the same number as 21.5, we get this weird situation where the same number, depending on how you think of it, could go up or down. So this is the flip point at which you start rounding up to 22, but anything right up to it could be going down to 21. So that's what we call it. So the upper bound is 21.5. Then we're going to need to do a similar thing to consider the width of the rectangle. Now the width is 5.3 centimeters. The next millimeter up would be 5.4. The next one below would be 5.2. So coming in there at halfway, we would have 5.35. So our perimeter is going to be, well, perimeter is the distance all the way around the outside, isn't it? So we could do 2 times 21.5 plus 5.35. Add those together and then times them by 2 in your calculator just the way that it is there would give you 53.7 centimeters. And there's the evidence of that. So that's all you have to chuck it into the calculator like that, but make sure that you're showing you're working as you go. Now the lower bound for the area of the rectangle. Now normally when we have these bounds questions, and particularly if they're going somewhere, a really nice way to get to your working marks is to make a bounds table. So just looking at what we've had already, if we say upper bound and lower bound, you've got your 21 centimeters, you've got your 5.3, and our upper bounds were 21.5 and 5.35. Our lower bounds are going to be 5.25, and halfway between 20 and 21 is 20.5. So the area of a rectangle is 20.5 times 5.25 is going to be the smallest give us the smallest possible answer that we could. Whack that into the calculator and hit S2D, and we get 107.625, and they haven't asked us to round it, so we don't. Moving on to question 2, pause this one and have a go. If you're thinking, oh, this is a bit harder than what we've been doing the first 2 days, then yeah, the first 2 ones, they were grade 5 stuff. We're up to grade 7 on this, so this is an old style grade A topic. The lower bound for the circumference of a circle. Well, the first thing to think about is the circumference is pi d, pi times the diameter. And if you're told the radius is 5, then the diameter is going to be twice that, isn't it? Because it's the distance all the way across the circle. It's been rounded to the nearest centimetre, so we're looking at the lower bound. We're coming in here. Oh, and thank you very much to the member of the Santa's Little Helper who's provided us with some new colours. We're going from, so that'll be 4.5 there. The upper bound would be 5.5. So the lower bound for the circumference of the circle is going to be, the circumference is pi times 4.5, and it says give your answer in terms of pi, so that just means 4. Oh, that's not right, is it? 4.5. What have I done wrong there? That's the radius, so I need to double that, don't we? I just write in times 2 there to get our diameter. That means that I'm actually going to be left with 9 pi as my answer. And the upper bound for the area of the circle, well, the upper bound means we're going to be using 5.5. The area of a circle, hopefully we can all remember as being pi r squared, so we just need to jam in 5.5 there, so the area is going to be pi times 5.5 squared. Now if it came in terms of pi in the non-calc, it would probably be in the non-calculator exam, so you would need to do 5.5 times 5.5 using a long multiplication method. I've actually just cheated and done it in my calculator, but when you get these ones, if you do that as a bit of practice, that would be good. You should, if you do your long multiplication on that, end up with 30.25. That's times by pi, isn't it? So your final answer is 30.25 pi. So pause the video and have a go at this one. And for this you need to consider what the upper bound and lower bounds of both of these are. So I would start by going for an upper bound and lower bound table. If you're confused, then draw a number line to help you along there. So our upper bound and our lower bound, corrected 2 decimal places, so we're going to be going halfway towards the next one. So 4.155 would get us halfway up to the next bit, and below that, let's just consider that because it is a little bit confusing. So we're going up the 3rd decimal place from 4.15 would be 4.16 would be the next up there, wouldn't it? 4.14. So we're talking about halfway in there, and halfway in there we're going to have 4.145. The T being really nasty now, 3 decimal places, but it's just the same thing. The next one up would be 2.517. The next one down would be 2.515. So we are looking at halfway in all of these. So the upper bound here is 2.5165 and the lower bound 2.515. And we want the upper bound for what V would be. Well, if you do a calculation and divide one number by another, if you're going to get the biggest number possible, you want to divide the upper bound, the biggest number that you have, by the smallest one that you could have. So we're going to have the upper bound for S divided by the lower bound for T. This would, by the way, be definitely in a calculator paper. So you're going to have the upper bound for S being 4.155 divided by the lower bound for T, 2.5155. In terms of the working that they expect to see to get full marks, they're going to want to see your 4.155. They're going to, and this one. They don't have to see these two, but I think it's a really good thing to do, because you can work those out without thinking about the other stuff and then which one you need. It's much easier to just work them out and then consider which ones you need than trying to do it all in your head in one go. Now that's giving me a great big long number here, 1.65. What does it want? To 3 decimal places. So if I write down to 4 decimal places, I can be ultra sure that I get the right answer by then putting a box around those. The 7 means I'm going to be rounding up, so it's 1.652. Just check back, there are no units at any point, so we don't need that. Okay, next question. We want the upper bound for V. So when you're multiplying, you do just want the larger ones, don't you? So we only want the upper bounds. Now you may well have worked out your lower bounds as well, and if you did that, then that's great. But just in terms of time, I'm going to just go for one. So 5.92 to 2 decimal places. The next up would be 5.93. So the upper bound is going to be 5.925. And for R, we've got 12.356. The next one up to 3 decimal places would be 12.357. So the upper bound there is going to be 12.356. So V is going to be I times R, 5.925 times 12.3565, and that should give you as an answer 73.212 once you've rounded it to 3 decimal places. Okay, there's one other kind of problem they like to put in here, and that is suitable degrees of accuracy. By considering bounds, work out the value of P. So pause the video and have a go at doing all the same things we've been doing up till now, and then see where you get to. If you get stuck at a point, then by all means just watch what I'm about to do now, and there will be a question 10 coming up will give you another chance to have a crack at it. So we want to know it to a suitable degree of accuracy. That means the point at which our upper bound and our lower bound would agree with each other. That might sound a little confusing. So let's start off by just doing the bounds tables. So if I just draw up my table there, upper bound, lower bound, E and T, 812 going up to 813 down to 811. Our bounds are going to be halfway between, aren't they? So we're going to have 812.5. We're going to have 811.5. T, 9.2. Halfway between those two is going to give us 9.15 and going up to 9.25. Right, so now P equals E over T. We're going to need an upper bound of this and a lower bound. So the upper bound, first of all, is going to be, remember we need the biggest value divided by the smallest value, don't we? So we're going to take the upper bound for E, 812.5, divide it by the lower bound for T, 9.15. And we'll put that in the calculator in a moment. The lower bound we will need the smallest value for E this time, which is 811.5, and we're going to divide that by the upper bound, 9.25. Now that's not going to make a massive difference, is it? But it will make a little bit of a difference. So if you put those into your calculator, you should find that what you get is, oh, here I am dribbling on, over 9.15. That gives us that S to D it 88.7978. 88.7978. I'll write down that many for now. On the next one, if I'm feeling lazy, I think I can just go back into here and that's not helping, is it? I'll just get rid of it. 811.5 over 9.25 gives us 87.729. Now, what we're looking for with this is the least accurate point at which these two both agree. And what happens here, if you round this to one significant figure, you get 90 to one significant figure. And if you round this one to one significant figure, the 7 also rounds that up, that's also 90. So it doesn't actually make any difference what we've done if you were going to round it. So they are both 90 to one significant figure. So that would be our answer, but you do need to write down what degree of accuracy you've rounded it to. Now we're going to move on to question 10 now. Pause the video, have a go at this. Now this one, it's not going to be one significant figure. You're going to have to go on a few more times. So take your time, have a little go, and then see if what you do agrees with me. Start by doing your bounds tables. I gotta do a little bit of almost silent teacher now, I think. Okay, so that's our bounds table filled in. So then we need to do an upper bound version of this. So f will be the square root of the upper bound, 12.75, divided by the lower bound, which is 9.2935, and then which will give us whatever it gives us, and our lower bound f will be the square root of the smaller value we could have, root of 12.65, divided by the biggest that we could have there, 9.2945. Again, these are going to give us answers pretty similar. For the upper bound, that should give you 0.3842163033 are all the digits I've got there. And for the lower bound, 0.38265431. I've just realised the way I explained it before was kind of wrong, because the point is, this is the 90 is the most accurate where they are the same. I said it exactly the wrong way around. I'm really sorry about that, folks. Look, 80, if I was to round this to the nearest whole number, that would be 89, wouldn't it? Whereas this one would be 88. So the most accurate time at which they are the same is when it's only one significant figure. Now if I look here, they're both 0 there, aren't they? Well, that's no good to anyone. But you start looking at the number and it looks they look a lot more similar, don't they? So if I've got the 0.38, they are the same as each other there. When I get to there, that looks different, and it is different, isn't it? There's no, if I was to round that up, that would go to 0.384. This would go to 0.383. But if I look at those, that rounds down to 0.38, that rounds down to 0.38. So because they both round down to that same number, I can say that f equals 0.38 to two significant figures, or you could say 2 decimal places, it wouldn't matter, giving a reason for your answer, and that's just because this is the most accurate value for which they both round to the same value. Don't tell your English teacher about that, not a brilliant sentence, was it? But it's good enough to get the marks in maths. Right, so now, as I said, I'd like you to have a go at question 13. And if you had trouble downloading the worksheet, then that is that. Now, I'd like you to do that for me, please, and upload that onto class charts. And then I will give you all some feedback about that at the beginning of Monday's video. That'll be exciting, won't it? Okay, folks, hope you all have a nice weekend, and I will see you next week.